Hey guys, so this is the last video for section 4.5, which is solving systems of linear inequalities. This video is just one problem. It's the one problem we didn't finish in our notes from the last video. This last problem is a word problem, so we are going to read through it and work through it together. So it says you can spend at most $21 on fruit. So I'm going to underline that because that's got to be important. At most $21. And I want you to think about that right now, actually, before we keep reading, at most. So we know this is got to be an inequality. So we were either doing less than or greater than. At most 21. So think about that. Does at most mean less than, or does at most mean greater than? So think about money. If you only have $21, can you spend 22? Can you spend 25? Can you spend 100? Or can you, if you have at most 21, can you spend 15, 16, $17? And hopefully you're thinking, if you have only $21 in your pocket, you can only spend something less than 21. So really think about it in context, make it real for yourself. At most 21. If something's for $30, can you buy it? No, it's got to be less than 21. Okay, so then let's keep going. Blueberries cost $4 per pound. Strawberries cost $3 per pound. You need at least, this is also important, so let's underline this stuff was good. Strawberries cost $3. You need at least 3 pounds to make muffins. Let's also dissect that word at least 3 pounds. So if you need at least 3 pounds to make muffins, could you have 2 pounds? Or 1 pound? No, you need at least 3, so that's got to be 4 or 5. So that's got to be greater than or equal to. These are actually both or equal to's. Okay, let's define our variables. So what two things are we talking about? We got really good at this stuff, guys. Let's say X is for strawberries and Y is for, let's go the other way around. X is for blueberries and Y is for strawberries. We got really good at this with the practice we did last couple weeks. Write a system of linear inequalities. So the two systems, we're going to have one is going to be about money and one's going to be about pounds. The one about money is we've got $4 for blueberries plus $3 for strawberries. We know that's how you represent it. What else is about the money is that 21. That's got to be less than or equal to 21. And then the number of pounds, that's just going to be the how many blueberries plus how many strawberries has to be greater than or equal to 3 pounds. So let's graph this system of inequalities. So when we graph, guys, we're used to our equations being in slope-intercept form. So that's y equals mx plus b form. Neither of these inequalities are in that form. We have to get them in that form to make it a little bit easier for when we graph. And so what we need to remember is we need to get y alone when we do this. That second equation is going to be easier. To get the y alone, just subtract that x over. And you'll get y is greater than or equal to negative x plus 3 is one of your equations. We're just rearranging it. Here we've got to subtract the 4x. So we'll say 3y is less than or equal to negative 4x plus 21. And I put that 4x first because the x is first here. Divide everything by 3. And I get y is less than or equal to negative 4/3 x plus 7. Because 21 divided by 3. So let's write this a little bit better. Our two inequalities are y is less than or equal to negative 4/3 x plus 7. And then y is greater than or equal to negative x plus 3. These are the same things, guys, just written in different forms. This is standard form, and this one's y-intercept form. And so now let's graph them. So let's look. I've got let's redo this one, y-intercept of 7. And my slope is negative 4/3. So I'm going to go down 4, 1, 2, 3, 4 over 3. Down 4, 1, 2, 3, 4 over 3. 1, 2, 3. Down 4 over 3. It is a or equal to, so I'm going to make that solid. And it is a less than, so I'm going to shade below. And now let's do the other one here. I have a y-intercept of 3 and a slope of -1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. Whoops. These are very close together, aren't they? And it is a or equal to, so it's a solid line. And it is a greater than, so I'm going to shade above. So which region has both shades? That's that tiny region in between. Has both shaded marks. Let's answer some questions here. Is it possible to buy 5 pounds of blueberries and 1 pound of strawberries? Remember, our blueberries was X and our strawberries was Y, so I wrote this right as an ordered pair. If this is a solution, then we can say yes. If it's not, then we can say no. So let's find 5, 1. 5, 1 is right here. Is that a solution? No, it is not in the double shaded region. And then our last question is name one combination that is possible to buy. So we've just got to pick any point in the shaded region that is going to be a solution. Now what we want to do is also be careful. We know we can't buy negative blueberries and negative strawberries. So really we are only looking at this part of the graph, that first quadrant. So I can only pick up really something that's in this yellow shaded region. I'll just go right here. Let's say 1, 3. That's X, Y. So we'll say 1 pound of blueberries and 3 pounds of strawberries. Okay. And that's how we break down applying systems of linear equations to a real life application problem. Good job, guys.